equations of a circle. And there's a few bits in this question, but if you take it nice and slowly and take it through to the end, you'll be absolutely fine. Okay, so the question is, the line L is a tangent to the circle, and here's your equation for the circle, and it touches the circle at point A, and we're given the point there. Okay. The line then crosses the x-axis at point P, and the last part of the question is you have to work out the area of the triangle OAP. Now, as I said, there's a few things in this question, but if you're stuck or you see a question like this, the first thing you need to do is you must start by drawing yourself a little diagram. Okay? We know it's an equation of a circle, so we're going to draw ourselves a set of axes. Okay? It doesn't have to be perfect, and on those axes we're going to draw ourselves a circle. Okay? Remember, if it's in this format, this part of the circle equation gives us our radius. Okay? This is actually our radius squared. Okay? Which means that my circle goes up to root of 40 and it goes down to root of 40 here. Okay? Now I'm going to put my line L, which is my tangent. Remember, it just kisses the edge of the circle. And it kisses it at 2, 6, so it's going to be about here. It's going to go down, it's going to touch the edge of my circle, and it's going off, and it's going to cross the x-axis there. Okay, that's line L. It touches it at 2, 6, and it crosses the x-axis at point P. Now, I haven't actually done any maths yet. This is all in the question. Okay, but it helps me get thinking about what we're going to do next. Here's my origin. Here's my point A. So if I want the area of this triangle here, O to A to P, I've got to find out what point P is. To find point P, I need to know what the equation of this line is. Okay? So to find the equation of the line, first of all I need the gradient. Now, I've only got 1 point on it, so I've got to use what I know about tangents of a circle. And a tangent of a circle always touches the radius at 90 degrees. So if I can find the gradient of this line here, OA, I can find the gradient of there. So let's think about it. The gradient of OA is the change in y, which is 6, over the change in x, which is 2, so my gradient is 3. Okay, so it's the gradient of this line here. For perpendicular lines, the gradients are always the negative reciprocal. Okay, so therefore the gradient of line L, okay, which is this one here, is the negative reciprocal of 3, which is minus 1 over 3. Okay, so that gives me the equation, the gradient of my line L. Now to find out the equation of L, excuse my shorthand, I'm going to use y equals mx plus c. Okay, m is my gradient, so y is minus a third x plus c. Okay, I need to find my constant there, and to do that I'm going to use a point on the line. I'm going to use 2, 6. Okay, putting this into the equation gives me 6 is minus a third times by my x value, which is 2 plus c. Okay, and it gives me a constant, if I rearrange this, of 6 and 2/3. So the equation of line L becomes y is minus a third x plus 6 and 2/3. Okay, remember that I've done this so that I can find point P. Okay, at P, my y value is 0. So if I want to find out the x-coordinate, which is point P, and I need that, okay, I have to put y is 0 into this equation here. Okay, if I put y is 0 into that equation there, what I actually end up with, and girls, try and pause it if you want and work it through, okay, but it gives me an x value of 20. Okay, so we know line L crosses the x-axis at 20. The last part it asks me is it wants me to find out the area of this triangle here, OAP. Okay, so what I'm going to draw is I'm just going to draw OAP down here so you can have a little look at it, not on our diagram. It makes it much clearer. Okay? If I make that O, I make that A, and I make this P, okay? I know that O to P, oh sorry, I've labelled them the wrong way around, not sorry, I'm changing them now. O, A, P, okay? I know that O to P is actually 20, okay? 20 across here. I don't know at the moment this distance here, which I'm going to need to work out my area, but I do know that this distance, O to A, is actually the radius of the circle, okay? And the circle radius we know is root 40, so I can say that O to A is also root 40. But I need this, okay? Remember, for the area of a triangle, you need half times base times height. This is my base, okay? So I need this, I'm going to let that be x, and I'm going to use Pythagoras, okay, to find out what it is. Now, Pythagoras on this would mean that 20 squared has got to be equal to the sum of the squares of the other two sides, so the root of 40 squared plus x squared here. Okay? Rearranging that to make x a subject, I'd have x squared is equal to 20 squared, which is 400, minus, now the square of the square root cancels each other out, minus 40, so x squared is 360, and therefore x is the root of 360, which is just 6 root 10. Okay, so I can fill that in here, 6 root 10. And the last part of the question is finding the area. Okay, the area of a triangle is always half base times height. Now for my triangle here, my base is 6 root 10, my height is root of 40, so I've got half times 6 root 10 times by root of 40. Okay, putting all of those together, it gives you an area of the triangle OAP of 60